So I'm going to be talking about the data center of the future, which is a very laudable ambition, but also cover why it may be a lot more difficult than we are currently expecting it to be. So just to recover what Melissa was going through, that's what we do. And we've been working on some interesting projects over the last 14 years or so. So we worked with the EU on the PEDCO, Eureka and Catalyst projects. We're currently working with Denez on the transport industrial cooling and refrigeration, and we're looking after the data center element of that project. We also worked with CHADCA, which was an Innovate UK funded project on edge DCs and their waste heat reuse. We're also embedded client side in the sustainability team at Start Campus. That's a mega hub down under construction in Portugal. It's actually, up until about 6 weeks ago, it was 486 megawatts of data center capacity, but they've just doubled it to 1.2 gigawatts. And I'm not going to cover that in any detail, but we're part of their sustainability team. And we're also working with the University of California, Berkeley, Suboptic Foundation, the Internet Society on the Sustainable Subsea Network project. And we're looking at our main focus is the cable landing stations, but we've been recently asked to look at the marine side of things because they're... Come in, gentlemen.
Thank you.
So we're on the advisory board of that project, and we're looking after the cable landing stations because they're very similar to data centres, and we've recently been asked to look at marine, although we haven't been officially engaged for that project yet. So what I'm going to cover in this presentation is where we are now, where do we want to be, how do we get there, and a possible future from how we get there, or an alternative future from how we get there. So back in 2021, I will say, because I did a presentation to the autumn lecture at the Birmingham Motorcycle Museum. I think that was in October, wasn't it? Yeah. So, and what I've done is, all the slides, I've basically reused the slide deck and just updated it and then added a few bits and pieces. So this was from 2021. And what we said is, and this is part of Melissa's article, that the IEA had estimated that data networks consumed about 250 terawatts in 2019, or about 1% of global electricity use, with mobile networks accounting for 2/3. And elsewhere, that estimate was 3%. And as Melissa just said, technological advances are difficult to forecast, but online resources predicts if left unchecked, data center energy use could surpass more than 10% of the global electricity by 2030. So remember, this is from 2021. And sometimes data centers are known as coal-eating, fire-breathing dragons of energy use. So I stole a slide from Game of Thrones there. So in 2021, basically, how much energy is consumed by data center globally? And we did ask that question to the audience. And to be honest, there was some really interesting high-low estimates on that one. And the fact remains that nobody knows. And even today, still nobody knows. Right? And I'll come on to that in a minute. But there was a report that came out in September 22 from the IEA, and they said that it was, in 2021, it was between 230 to 320 terawatts globally, or about 0.9 to 1.3% of global electricity demand. That's actually a 46% variance, right, between 220 and 320 terawatts. So that, to be honest, from research purposes, I don't see that as being particularly useful, because it's really wide. And you can look that up on their website. And then they produced a 2024 update back in February, I think. So in 2021, we knew that the EU demands for data centers were between 53 to 76 between 2020 and 2018, and this accounted for 2.7% of the electricity demand in the EU. And it was expected to increase by 21% to 92.6 terawatt hours by 2025, next year. And then how much consumed, this is a question for you guys actually, how much energy was consumed by the UK data centres between 2021 and 2023? Now, if you've done your homework, you can go onto the website, the Climate Change Agreement website, and you can actually download the target agreements, which we have done. But we've also, because of the Ticker project, been given some unredacted data, which I will cover, but you didn't hear it from me. Right, the problem is that all of the data we have is based on a flawed approach. The Code of Conduct defines a data centre as all buildings, facilities and rooms, enterprise servers, server communication equipment, cooling equipment, power equipment, and which provides some sort of data service. So that's hyperscale all the way down to a server room with maybe 1 or 2 cabinets in, which as long as it's cooled. Whereas the Climate Change Agreement in the UK kind of adds, it says it's at least 200 kilowatts and that it's a commercial operation. All right? But the report from the IEA analysis reported energy use data from largest data centre operators, but there's no comprehensive data on the energy use of all data centres operated globally. So this estimated range is based on bottom-up models from sales figures, i.e. the sales of servers, available energy use data, so some of the climate change agreements and other mandatory reporting that's required in certain states, and also data from large data centre operators. And this is why we've got that variance between 220 and 320, because they can't agree on the actual scope of the study. Essentially, a large pile of manure in a field. The Americans really loved that when I presented that last year in August. So what about this update that I was telling you about, the Electricity 2024? So they're basically saying it could double by 2026. So now they're saying it's 460 terawatts, almost 2% of total energy demands. Now, when this came out, there was a few people that got really, really annoyed about it in the industry. And some research was done, and it turned out that the guy that had done the original report now works for somebody else. And the guy that done this report is a bit of an intern. So I would treat that with a big dollop of salt. And this is what he's basically saying, is that it's going to be cryptocurrencies and AI. Now, personally, I see crypto as a parasitic type of data center. I don't think they serve any useful purpose for man or beast, and we should shut them all down, to be honest. But the use of blockchain, however, is going to potentially be useful. But crypto, no, get rid of them all. But as you can see, the largest increase is in, well, they reckon that dedicated data centers is going to double as well. And then we're going to have a big chunk of AI data centers. And he's, to be fair, he's got some good sources there. I'm still a bit sceptical about them. But so I think it's more large piles of manure in a field. Because actually, what we're looking at is the top of the iceberg, and that is more like what it's going to be. Right, so we've got the headlines up here, the top stuff, that's the 230, 420 gigawatts, terawatts. But when you look into it and think about your content delivery networks, your POPs, your small server rooms, that then widens it out big time. And I think the government and policymakers are doing themselves a disservice by refusing to include distributed IT in their figures. So I think this is when your latest article, Melissa, wasn't it? That we said that in the second period, which would have been 2014 to 2015, the data centres made up 0.79%. And I felt it was actually more like 12%. And we still don't really know, but we do have some data from the second period of the Climate Change Agreement, which was published in December 17. So this is all from 2021. And that was 2.579 terawatt hours for data centres in that 2-year period. And in the third period, because we didn't have that information at the time, I think it was just about being collated. So basically, Tech UK and I think the Environment Agency said that the sector performed well against its third milestone, and we've met the efficiency target, which is the third of 4 milestones in the life of the scheme. They fulfilled the final scheme target 2 years ahead of schedule. Well, that's all very well and good if you're looking at something that's static, but actually the number of data centres in the UK has increased since then. But they said at the individual facility level, the picture is more mixed. It ends in 2023, but they have extended it. And who knows what this new government will do? They might relook at it again and do some other chicanery on it, which is what we've been asking for, actually. But it says, whilst the commercial sector is heavily scrutinised, we still need to tackle the lingering problem of distributed IT. So that's your POPs, your edge sites, and your server rooms. So we still don't really know. But what we do know for the commercial data centre, so for the 5th period, and I'm expecting a gasp here, from January 21 to December 22. Right? So that's actual verifiable CCA data, which you can download and look at, right? 9.65 terawatt hours. And that's just between the 21st of January 2021 and 22. Now, I went back and looked for all of the climate change data. And in the first year of operation, it was around 800,000. And then it went up to 2.579. Then it jumped to 8.8. And then it jumped up again to about 8.9 for period 4. So I suspect that the 2.579 was actually a vastly underreported time. But now we have good visibility. And since December 22, there has been more assets put online. So that figure is probably nearer 11 terawatt hours now, I would say. So in this 5th period, there were 65 organisations in the scheme. And the average PUE, so those who don't know, is power utilisation effectiveness. It's basically a ratio of the power that goes into the facility divided by the power that's used by IT within the facility. So the remainder is your support and associated services. So cooling systems, leak detection, fire detection, security, blah, 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 blah. The global average from Uptime Institute is 1.55. So we're a bit above where we should be. But of the 65 organisations, 30 did not meet their target. Now, because of the ticker data, I've had another look. And I have to say that most of the people that have got PUEs that do not meet the target are actually legacy estates. And also, quite interestingly, a lot of managed service providers in there. And they might be people that have taken over estates from their customers and looking after them, but there's no budget in the contract to improve what they're doing. So they are leaving it as it is. There was actually one operator, I'm not going to mention them by name, but they've got 8 sites, and one of them was 2.85, right, in a PUE, and that's absolutely appalling, right? It really is. That you might as well just stand on the steps of the data centre burning £50 notes, because that is outrageously, it's just so inefficient. They had a tin roof. Right, so in the summer months, the tin roof was basically including the heat, and then the air conditioning system was ramping up to get rid of that heat. And I said to the guy, just paint the roof white. So it's simple things, right, that you can do to this. So this was from a Science article, and it basically says assessing the implications of growing demand requires robust understanding of the scale and drivers of data center energy use. That has eluded many policymakers and energy analysts. Blind spot, historical lack of bottom-up information, and it's often led to sporadic and often contradictory literature on global data center use, as we've seen. Right? You know, you can ask different people in different jurisdictions, they will give you different answers, and there's no real global view of this. So this is some estimates. I mean, I'm just going to flick over this because they're just estimates, and you know, they're just useless given the growth. But there were some good recommendations in that science report. So they want policy support on energy efficiency standards and IT equipment. That's actually been done. There has been investment in new technologies. Martin's going to show you something later on. And on public data and modelling, I would say that that's a work in progress. But we can't wait for another decade to get actually verifiable use. So these are new projects that are coming online this year. So Havering, potentially 600 meg, London Borough of Tower Hamlets 72, London Borough of Newham on the old Talent Lyle factories 210 megawatts. The ones with stars are actually bona fide projects that have got planning permission. The rest of them a bit iffy perhaps, but 2.9 gigawatts of new capacity. But there is an elephant in the room, and I've particularly chose this picture because it really is something that we all need to think about. So, this is the national grid, live data in about 14th of September. And what I want you to focus on is the transfers, right? So this is imports from Europe. 4.4 gigawatts of power was coming in over the 5 interconnectors. So we've got France, Belgium, Netherlands, one over to Ireland, and the Norwegian one, right? So 5 of them were inbound 4.4 gigawatts into the UK at an average strike price of £52 per megawatt. And if you notice, it's 14.2% fossil fuels and 47.5% renewables on that day at that time, right? Now, this one I took on Sunday, right? 3.4 gigawatts, and if you can see, we were actually bringing in power from Ireland, right? No doubt because it was quite windy over there. So that actual link is very variable. No price. It's probably the weekend, so the brokers weren't in place. But with 55.1% fossil fuels, right? And only 16.6% renewable. So we're already importing between 15 and 20% of the entire country's energy needs from Europe on a daily basis. And then we get people from the National Grid CEO, data centre power use to surge 6-fold in 10 years. Right? So that's from, let's say, 9.65 terawatt hours up to 60. From the Telegraph on Sunday, the age of energy rationing. Now, I know the Telegraph is a bit, they're always going to jump on Ed Miliband and energy policy and all that sort of stuff. But that was quite an interesting article that I read. I just took the headline because I'm not a great lover of the Telegraph. But the article does raise some interesting points, right? So our nuclear fleet is going to be shut off by 2028 because it's already had its life extended. So that will take out we're currently getting 3.87 gigawatts, so that will go down to 0 unless they find a way of keeping it going. So unsustainable, not able to maintain at the current rate of level. Boom, ecology, depleted natural resources. I don't think that our ambitions for the 2.9 gigawatts of new capacity stack up well with our actual energy capacity. And I know this is something the Labour government are looking at doing. So this is why they've created GB Energy. This is why they've got the Rolls-Royce and the SMRs, a small modular reactor program. But we looked at the small modular reactor program, and the final decision date for the investment is not until 2029. So it's not going to help us meet our short-term energy needs, but potentially would be in the future. Right, so that's where we are now, right? We've got a data center installations on a growth, and we've got our power systems probably on the way down, and there isn't a bit of a gap. So we do have an energy gap. Right, so over in the EU there is some legislation. Right, so here's the data centers. We've got the Taxonomy Climate Delegated Act, or TCDA. Now that is for green financing for data centers. So you may have read recently that certain companies are getting green financing for their data center build-outs. And that's normal money, normal capital finance money, with some green hinges on it, and basically they get probably 1% off of the rate, right? But in order to do so, they have to comply with the Taxonomy Climate Delegated Act, and there is an assessment framework that I helped contribute to, which basically says all data centers should use the Code of Conduct for Data Center Energy Efficiency and report the metrics, which we will cover later. So that's to build them. Then we've got the Corporate Sustainability Reporting Directive. So if anybody doesn't know what that is, that's the Scope 1, Scope 2 and Scope 3 for large corporate entities, which they need to report. So that's upward pressure, and potentially from clients, so customers and clients of data centers. Then we've got the Energy Efficiency Directive, which was published in March, and that's downward pressure. So under the Energy Efficiency Directive, they have to report their total energy consumption, the percentage that's derived from renewable energy, their waste heat reuse, and their water use. The deadline for that was the 15th of September across all the member states. So we're exempt from that at the moment, but we obviously keep in touch with our partners over there. The Dutch portal closed on the 15th of July, and 55 data centres reported. Of the 55, 5 had produced actual meaningful data, and 50 of them had cited privacy concerns and they didn't provide any data. Now that's all very well and good, I can understand that. But what will happen is the Commission will get antsy about that and go, no, that you're not abiding by the spirit of the legislation, and we'll just strengthen it, and we'll just say you will provide that information, otherwise we'll just fine you out of existence. France has had one for about 4 years. The Germans are in a flat spin because their Energy Efficiency Act is really, really onerous. And anyway, the Commission portal, which was supposed to be ready by the 15th of September, was only actually went online on about the 6th of September. And they said, we haven't extended the deadline, but we are going to leave the portal open for a bit while yet. So I'm not quite sure whether they've extended the deadline or not. Anyway, then you've got your Corporate Sustainability Due Diligence Directive. So this is basically modern slavery and things in the supply chain, and making sure that they're all above board. So that doesn't apply directly to data centers, but it could apply to their supply chain. So the manufacturers and equipment of stuff that's going into the facility. Then if you're a bank or financial institution, you've got the Digital Operations Resilience Act, which calls on the bank or financial institution to do third-party checks. And of course, if they are using co-location sites or cloud sites, they have to make sure that they are compliant with the requirements under the DORA. It's not the Defence of the Realm Act, if you remember that. And then we've got the Climate Delegated Act of 2025, which I'll come on in a minute, but that's going to be based on an actual standard. And then finally, we've got the climate transition plans. So all of the data, or any company actually over a certain size has to have a climate transition plan in the EU of how they're going to get from where they are now to where they want to be. So that's the legislation that's happening in the EU. We don't have anything like that in the UK yet, but it will be coming. You may have seen a couple of weeks ago that the government has designated data centres as critical national infrastructure. Now, this has been a big topic of conversation. This, I think, we had the Data Centre Dynamics event the week after, and there was a lot of buzz. Oh, great, we're now part of critical national infrastructure. It's really good, we've got all this protection, blah, blah, blah. But I'm sitting there and saying, no, you need to look at the fine print. The devil, as always, is in the detail. This is what the government said Data centres powering the economy will be designated as critical national infrastructure alongside energy and water systems. Okay, somebody in the audience, tell me what an energy or water system looks like in terms of legislation in the UK. Anybody? Heavily regulated. Water Act, Electricity Act. They even have their own departments. Ofwat and Ofgem, is it? This is dangerous, right? Because, and I'm really looking at my colleagues and saying, do you realise what CNI actually means, right? It means they're going to legislate you big time. The managing director of Equinix was really quite happy about it. He welcomed the announcement, and he said, the digital infrastructure is the fourth utility, and is now a service that the people in the UK can no longer live without. Okay, well, yeah, that's a double-edged sword, my friend. And they were happy to have played an important role in the consultation process, so they did that via Tech UK. So, energy infrastructure, problem, the potential of data centre regulations, not there yet, but we will probably be asked to shape some of them. New power stations, so when I say new power stations, I was talking about Sizewell, Hinkley Point C, right, which was mooted to have been £18 billion and be ready and operational by 2025. So the last update report in January said it was going to cost £31 billion, so it's doubled in cost, and it won't be producing until 2032, right, or 2036. Sizewell C has yet to break ground, right, so I can't see that happening anytime soon. Now we've got the new nuclear, so I've put new nuclear in. So this is small modular reactors, but as I said earlier, that decision won't be made until 2029. I do suspect the government may bring that forward, but the UK does have quite a robust nuclear regulatory regime. So the design has to be approved by some bods at Sellafield and in the Donez. So, and that process, I mean, they put that timetable on. That was a Tory government timetable. It may be accelerated, but the problem is that since 1986, which was when the last time the UK built a reactor, all of the people with the knowledge and skills about how to do regulation have kind of like either unfortunately passed on or moved into other countries to give them their nuclear regulatory stuff. And you may have heard about the Great Grid, the Great Grid Upgrade Scheme. Every time I look at it, it changes. So first of all, it was 9 billion, then it's like 18 billion, and now it's 30 billion of upgrades. There's 18 specific projects. There's a 9,000 entry pipeline for connectivity, either to or from the grid. There are some code changes that are coming in from the national grid. So yeah, I'm kind of optimistic that we'll get this done, but you know, I'm looking at the industry and thinking we want to get our data centres built and running in 2 years' time, and then I'm looking at the background of the energy side of things and saying, nah, not a chance. And then of course we've got the disruption, environmental issues and costs. I mean, just bringing in, I think there's a connection that's from a wind farm in Norfolk, and it's going to be the width of a motorway in terms of the power lines, and the local residents are already up in arms about that, and you'll see more environmental stuff going on about this grid infrastructure. It'll be substation, people complain about new substations, people complain about pylons, people basically saying we need to go underground, and then moaning about undergrounding. I mean, it's a real hodgepodge of potential minefields. So, where are we now? I think we've covered that. We still don't know really, right? Because we're not measuring everything. Where do we want to be? More. How do we get there? Not quite sure yet. And the possible future we will cover in a moment. So, change of direction. Climate change means, in my opinion, opportunity, right? Business models have to change. I think we need to go from a consumptive model to more of a XaaS type model. But that's not just for telecoms, that's for everything, right? You consume what you use, and you leave the operator to deal with the slack periods. Now, I was looking at all of these construction projects, and I was thinking, have we got enough plant in the country? And when I say plant, I mean construction diggers, bulldozers, cranes, etc., to do this. Now, I don't know if many of you recall back in the Olympics, so almost 50% of our plant was being used in the 2-3 years prior to the Olympics, actually building Olympic venues, right? And there was a couple of hospital projects, and you couldn't get a digger for love nor money, right? So I'm not convinced that we've actually got enough plant in the country, construction materials, and I'm sure we haven't got enough people that are skilled in construction to do this, because they've all gone off to other projects as well. So business models have to change. Carbon taxes are coming, and that's, by the way, that's the labour of Hercules, and those are the labours of Hercules. Just thought I'd add that in, just in case you were a bit confused about why I'd put the lion up there. So in terms of sustainability, so I'm going to cover a number of things. So sustainable buildings and decarbonised grid, and you may see some of the ones are greyed out. So in sustainable construction, it's almost impossible not to build a sustainable building nowadays, right? If you commission a building, your architect and your main contractor will kind of tell you that you need to go down certain routes. And what will happen in the future is you won't be able to buy conventional stuff that you used to be able to build. So, you need to think about water efficiency, indoor environmental quality, the durable maintainable design, energy efficiency, sustainable construction materials, and waste reduction. And the Net Zero Green Building Project basically said that in order to meet the world's net zero goals, all buildings built by 2030 need to be net zero carbon. All new buildings. And by 2050, all buildings need to be net zero carbon. And that is from measuring your carbon, reducing the energy demand, generate your balanced renewables, and improve verification bigger. So that was in March 2018. Nothing's really changed. In fact, there are some very good projects. So we're working on a project in Sweden, and they're using glulam, which is cross-laminated timber, as their superstructure for their data center. And because that's lighter, they can use a smaller foundation, and the foundation is actually supplemented using biocretes and biochar. So it still has the same strength, but it emits considerably less carbon. Concrete, I don't know if you know, it's like 1 ton of concrete, 1 ton of carbon. So using these techniques, and we've actually been looking at industrial hemp as well as internal and external panels. Decarbonising the grid. Okay, wind, solar, biomass, blah, blah, blah. So this is from GridWatch on Sunday, and these are all the kind of types, but you look at the demand of 34 gigawatts, and of it, 14% was renewables and 16% was carbon neutral. So there was a lot of combined gas turbines on grid on Sunday. Nuclear is considered to be green, by the way, or from a carbon neutral source. Biomass, we had a lot on, that was probably Drax. There wasn't a lot, there was a bit of wind, 3%, no solar, it was quite rainy on Sunday, I think. No coal, we've just shut down our last coal-fired power station, so that you won't see that in future. Pumped hydro anyway, my point being is that the grid is not decarbonised yet. And I did an AI search for this, and this is what I got. So the government is committed to decarbonise its grid by 2035 as part of its net zero plans. This will require significant investment, planning and coordination across the government and private sector. Some of the challenges, this is from AI, remember. So the Climate Change Committee anticipate UK energy demand 50% higher than pre-COVID levels by 35 and 100% higher by 2050, largely driven by heat pumps and electric vehicles and potentially data centres. Infrastructure. New infrastructure needed to connect, offshore wind farms, solar, homes and businesses, grid, building new grid infrastructure takes a long time. They're not wrong there. This AI bot, whoever it was. Technologies, so away from fossils, adopt new technologies, electric vehicles, heat pumps, and then bring the public with you. That's going to be interesting. But others said it can be done with rapid reforms, and others say it's ambitious and will not be achieved by 2035. I put myself in that camp, actually. I think that the scale of the transition is so vast that we'll be really, really lucky if we get anywhere near it by 2035. Do we need to rethink our AI ambitions? And that is a huge project and proposal. Personally, I think that I'm not convinced that AI is a thing, a proper thing. I remain to be convinced. I'm actually going to be delivering a presentation next week at the Data Center Alliance Transformation called Stair AI to Heaven, or Stairway to Heaven, or Highway to Hell, right? Because AI is good in terms of things like identifying cancers, healthcare technologies, looking at climate change, where you're sifting through large amounts of data and trying to find anomalies. But it also can be used for deep fake, conflicting messages. It can basically affect our democracy, and it's going to put a lot of people in the lower paid industries out of work. So there's a recipe for social change on that one. So I think we need to rethink it. Unfortunately, my colleagues in the American data center industry just want to build these massive data centers full of AI stuff and get on with it. There we go. My colleague at the Data Center Alliance has described me as the Grim Reaper. Right, so conclusion. Now this is an interesting, and this is an old slide. It's from a colleague of mine who was an IBM Distinguished Engineer, and it was delivered for the BCS. When he retired, he bought himself a plot of woodland in Wales, and he wanted to see if he could use the Internet of Things to manage it, but he called it the Internet of Trees. And during his research, he actually got himself some sensors made up. They were solar powered and everything. It didn't work very well because obviously the leaves prevented the solar power. Anyway, that's a long another story. But what he did, he looked through. So before 1990, there were 6 elements on the periodic table that were used in the computing. In the 90s through to 2005, there was another 8 elements added. This is what's being used now. Right? Over half the periodic table is used in compute, and a lot of these ones at the higher end of the atomic numbers are rare earths. Very difficult to find. And I think sooner rather than later we're going to be going urban, we're going to go landfill diving, right, to find some of the stuff that we've dumped in the past. E-waste is a horrendous problem. We need to be capturing it and keeping it in the country so that we can mine those resources. But by the same token, the manufacturers have to be able to make them recyclable. Using laminated stuff and amalgamations of materials without considering how you deconstruct and recover the material afterwards is not going to be good moving forward. So I spoke about the legislation. If you recall this slide, I think legislation will force the issue. It already is. So what is a regulation is a secondary legislation. It sets out detailed requirements and usually to implement the principles and objectives of the primary legislation. So more broadly defined, regulations is a set of rules, incentives and penalties to change the behaviour of individuals. Right? So that's the key point here. It's what I'm making is change. And it's already making people change their data centre designs in Germany because of the harshness of the Energy Efficiency Act. But it also means monitoring performance and enforcing compliance. So I think that legislation will force a radical rethink. Now, going back to the IEA, they basically said that energy efficiency is the first fuel, which shows its significance. We need to do more with less, right? We need to reduce stuff and do more of it. And people will argue, and they cling on to this like a drowning man clings onto a lifeboat. During pandemic, data center energy efficiency, or data center energy was flatlining, but the productivity enhanced by 60%, right? So they're basically saying that we're okay, we're good, because we're doing more with the same amount of electricity, but you're building more of them, using more electricity, right? Just because you're flatlining and you're doing more production doesn't necessarily mean that's a good thing. So I'm basically saying we need to do more with less. So we've got a code of conduct, which is 160 best practices in data centers and cable landing stations, potentially telcos as well. And again, if we go back to this slide that we saw earlier, right? So the Taxonomy Climate Delegated Act, based on the Code of Conduct, Sustainability Reporting Directive can be used, the Code of Conduct can be used to report. Energy Efficiency Directive cites the Code of Conduct in its legislation, and also the ISO 30134 metrics. The Corporate Sustainability Due Diligence Directive cites the Code of Conduct. The DORA cites the Code of Conduct. The Taxonomy Delegated Act is likely to be based on the standard, and we're going to cover that in a moment. And then we've got the climate transition plans. You can use the Code of Conduct as a mechanism for your climate transition plans. We looked about scopes. Everybody knows what the scopes are, don't they? Yes? No? Yep? No? All right, so GHG scopes, scope 1, scope 2, scope 3. Scope 1 is the energy that you use on site, so purchased vehicles, or energy that you use in your own diesel generators, for instance. Scope 2 is purchased energy, steam, or heated and cooling from a third party. And then basically scope 3 is everything else, both upstream and downstream. So the amount of products and materials that you're using and the amount of products and stuff that your customers are using needs to be calculated if you qualify, which everybody will. And this is another AI thing. So this was, I wanted to see what energy efficiency, see what the AI would come back with. And it basically was saying things like this. I'll let you flip that. Are you recording this?
Yeah.
Oh, fine. Okay. So you can record this and look it back on our polite when we've got the slides anyway. And then this is what this is AI's definition of how to improve the data center. And to be honest, all of those are included in the Code of Conduct. So data center of the future, sustainable buildings kind of will happen by default, I think. Decarbonised grid, iffy in the UK at the moment, but potentially better globally. Rethinking our AI ambitions, not a prayer. Not a prayer. These guys, there's so much money being invested in AI data centers at the moment and AI. And you know, one of the reasons why? I don't think it's about AI itself. I think it's because the potential return on your investment is so big. Right? So if you're a person of, you know, considerable wealth, and you distribute some of your wealth, or you invest it in wealth funds, if you go into property, commercial property, you get probably 1% of your money back. You go into data centers, it's 18. So for them, it's a no-brainer, which is why BlackRock have got a, you know, £30 billion chest of stuff to build stuff in. The problem is with data centers is there is no globally recognised definition of what a sustainable data center looks like. We've got this, these are 2021 stuff. So we've got the Code of Conduct, which kind of alludes to it. We had the 99-1 best practices, which has now been withdrawn. The best practice for sustainability, which is now withdrawn in favour of this. This is a standard that will be used by the Taxonomy Climate Delegated Act. It's a new standard. It was published last year. It's the data center maturity model. It has 8 pillars and 5 levels of maturity. This will be used in the future for the taxonomy, and will probably be used in the UK as well, because it's a regional standard. And then we've got the ISO IEC 30134 series of data center KPIs, PUE, WE, etc. This was published in 2019, so it's 5 years old now, but we must rethink how we design, build and operate next generation data centers. And it defined it as renewable energy 24/7, 365, net zero results in carbon footprint, emissions and waste, It does this whilst maintaining 5 nines uptime and achieving optimal resource usage effectiveness, such as a PUE near 1 and a WE near 0. We're a long way off that yet. So the future, only a couple of small slides and then I'll hand over to Martin, who's going to talk about one of the things I've got on the next bit. Sustainable construction. So as I said earlier, we're looking at cross-laminated timber and glulam for superstructures, eco-concretes for foundations, and industrial hemp for internal and external panels. If you haven't come across hemp before, it really is the silver bullet for a lot of things, right? You can eat it, you can use it as medicine products, you can build out of it, it's just, you can smoke it if you want to. In terms of energy, right, so we've got the decarbonised grid, solar, wind, hydro, tidal, new nuclear, on-site small modular reactors, fusion. Now I haven't mentioned fusion. I've actually had the honour of being at the Jet Cullen Laboratory 3 times in my life, and I've actually seen inside the tokamak during a fusion experiment, and it is quite formidable. The next phase, they are building one in Nottingham, which is a commercial grade torus, and that should be operational by 2040. But knowing our energy always delayed, it's probably be 2045. But I'd like to see that happen. Big focus on microgrids, so this is using SMRs, but also submarine grade reactors. Now, they are very advanced, but they haven't had design approval yet, and there's a big push on the States because, funnily enough, a lot of the American data center guys are ex-submariners. But we can use grid flexibility services because remember, we do have backup generators and battery energy storage solutions, and there are people that have been experimenting on UPS and backup generators. So that's a potential there. Excuse me. Waste heat, immersed compute, district heating. We were discussing this earlier. I don't think that's a viable thing. It has to be done on a very small scale. But I can see local heat users, industrial process, laundry, textiles, urban greenhouses, etc., next to data centers to use that waste heat. Compute. Now, this could be the massive game changer. Graphene is a very interesting substance, and there have been some research on graphene chips that is in the process. I would not be at all surprised to see graphene chips available commercially within the next 3 to 5 years. If that happens, it really will be a massive change because they don't give off any heat and they use less electricity. And the other thing is that we could go to direct current systems in data centers. Now, I know the guys in the telco market have been using DC for a long time. It didn't really hop over to data centers, but maybe they should consider it. But they don't understand DC, and they get a bit scared of it, which is wrong, but that's the way it is. So I think this is actually quite exciting. It's going to be an adventure. It's a good thing that's happened because it's going to lead us all down an interesting path. So let's just be open and see where it takes us. The last thing I was going to say is we've just opened the National Data Center Academy in Leamington Spa, which is a practical data center skills academy. We're also looking to attract people that are doing cabling. So you can basically do some cabling training for your technicians and engineers in what looks like a real environment, but it's not going to affect any customers. So if you want any information, we've got some open days next week on Monday and Wednesday. So you can use that link to get the ticket, and that will be the website. It's not live at the moment. I've just had a message from my wife saying actually we're going to publish it and be damned. There's a few minor errors on it, but we're just going to publish it. So thank you.
Thank you so much, John. I told you knew what you were talking about. It was amazing. I really appreciate that. Thank you. We're going to do Q&A at the end, so I'm going to hand you straight over to Martin Bradburn now. I'll just give you some of his backstory. All very impressive. So Martin has 26 years of board-level technical IT experience, working for managed service providers in the UK and North America, delivering many significant public and private sector projects. So Martin set up Peasoup in 2014 to create a UK cloud service company, the first in Europe to use a hyper-converged architecture to ensure resilient and enhanced performance, offering easy-to-manage backup, disaster recovery and infrastructure as a service. Peasoup is an award-winning eco-cloud provider dedicated to its environmental responsibilities, consuming up to 20% less server power by using liquid immersion, something we're keen to explore this morning. There are many other operational benefits, but the immersion cooling's efficiency provides a much greener alternative to traditional cooling methods. By consuming less power to cool the same amount of processing capability, this aligns perfectly with their sustainable strategy. Over to you.
This is one of those where the water's just going to slide down and spill everywhere. Hold on to it. Right. Hello, everybody. So thank you for the introduction. Yeah, we're a cloud company. You'll see why and the details about what we do, I guess, as this goes through. But there are some uniques that follow on nicely from where John's been. And I'll give you some of the reasons why we're some uniques. The driver, clearly, climate change. The driver is looking at the impact of the climate throughout not just this country, throughout the world. And the frustration from our point, we look at data centres and they'll tell us that they're 100% efficient, will tell us that they are heading towards net zero, they'll tell us all of these wonderful things they're doing and all these renewables that they're using. And, sorry, I need the mic, I do apologise. They'll tell us all these wonderful things and we just kept looking at this and thinking this, every data centre is not the same and every data centre is not doing this, we've got to cut through this somehow. So we were looking for a way to cut through it. So, from the outset, we're a small business. The only way we can compete on a stage is by being innovative. We started out in this hyperconverged before it was even called hyperconverged, but we did it because of the cost benefits, the savings we could bring, the benefits we could add that would allow us to compete on that stage, on that bigger stage. And then we moved into liquid. We specifically looked at liquid cooling because, again, if we're ahead of that curve, and we know we can make savings in that space, we can pass those savings on and we can then remain a competitive organisation. So we've always been about looking at modern technologies and how we use those to drive us forward. Apart from that, we're a standard cloud service. We follow all the regulations, we follow all of the standards, all of the processes. There's nothing that we do any different to anybody else. We've just got to look at clever ways to make it happen. And one of those ways was to look at how do we make climate different, as opposed to just telling you we're planting more trees and we're using hundreds of percent sustainable energy and we're using all of the things that everybody else is saying. We had to find different ways. So we looked at all of the key areas. Consumption, water consumption, so not really touched on, but there's just, I will go into that because it's an enormous impact at the moment. Looked at the areas where there are lots of costs. So we were suffering for a while with hardware supply shortage, but we want to elongate the length of the hardware. We want to make sure we get as much out of that as possible. We want to minimise the amount to spend on air conditioning, minimise the water, and obviously reduce the energy. And if that also helps our maintenance costs, that's even better. We can maintain a cost-effective position. So just touching on PUE, I'm not going to go into masses of detail. It's interesting John's figures because I really struggled to find genuine figures on PUE. I've had to do a presentation and I couldn't even find the exact number of data centres in the UK, let alone the other power and the PUE of them. But I do know, and I'll give you this from a personal perspective, there are still some around that 2.5 mark. I know I went for my first data centre and I had to put a fleece on to walk in. It was absolutely freezing. It was a 4-storey fridge, quite literally. And then to improve the efficiency, there's lots of tricks that have been pulled, so increasing the temperature being one of those, or using water to compensate for the cooling to be able to make sure more water, to the point that it's ridiculous amounts of water. Olympic-sized swimming pools just daily being poured into data centres to keep them cool. It's crazy. So I went from the 4-storey fridge to what I now class as the Spanish runway. It is so noisy, so hot. You may as well be sat there next to a jet engine. It's you need to get into the cold aisle just to survive. It's one of those that you're literally trying to avoid now, and that's got us down to this, this 1.5, 1 point, sort of average position. 1.2 probably the latest best that would be achieved, but still not great. So driving this though, I'm going to use the fact it's an old slide, but it's actually still very relevant because we have this increase in power continuously coming around the corner. These are just based upon some of the, specifically some of the CPU, GPU type modules that are coming through. It's interesting though, because we always see it, what we see here is then like a 5-year window of how that's going to get deployed over a period of time. So we are seeing these 500 watt CPUs now. It's taken time for them to get there. That was 22 and we're now seeing them sort of filter through the systems. The latest stuff I saw last week was designing for 1.5 kilowatt chips, which is the combined, effectively, where the GPU, CPU combination of Intel is going to come in through. The servers we've just been putting in, and bearing in mind, ours aren't for AI, ours are standard cloud servers. In fact, these ones were storage servers. These were running at 570 watts. So it's just a forever increasing model. And everybody focuses on CPU. However, CPU is not really the entire position, it's the chip in general. So, if you look at the additional demands there, obviously John's talked about the data center demands which are going through the roof. Consumer devices will be coming down because they'll be a lot more efficient because that's what people are going to be seeing, and batteries are going to get more efficient in terms of putting consumable devices together. But the network is probably one of the areas that's least thought of, and yet one of the areas that's got the most growth. The amount of processing power that's going into networks now and the amount of additional power, additional heat that's being generated in that space. We see it, as we've done some analytics on the servers that we're using, we're seeing so much heat generation from network, it's crazy. But everybody focuses just on CPU because it's the headline figure and easy to work out. So, liquid immersion, what's it about? Why do we do it? Effectively, we take a dielectric liquid, we surround the server in dielectric liquid, we move the liquid round, it withdraws the heat from the components, and then we can use it elsewhere. There's a couple of systems out there. We use a single phase position. It means that as we're pumping liquid round, it has to be cooled, so there's a secondary loop that comes around and cools it, but we're taking heat and we're transferring heat from one place to another without it being in the atmosphere, without it going into the air. So we take the heat from the servers and we take it around effectively a water loop, and it can be moved off to a dry cooler, no longer needs to be chilled, or it can be moved off to a secondary source. So the way we look at this now, if you look at air conditioning, liquid provided for air conditioning is probably around 12-14 degrees to get to the air, to blow the air across the data center. We'll quite happily take 30 degrees in. We don't need that sort of, it doesn't need all that energy to reduce the temperature. We can quite happily take 30 and we'll return about 40 within our system. So that's just the basic principle of what we do. Are we stupid doing it? Is anybody else doing this? Well, the whole principle came out, funnily enough, I know you hate Bitcoin, but it all came out from Bitcoin. The importance of Bitcoin is that the money spent impacts the value of the coin that you're mining. So there are sites, and these are two genuine sites, where it's just an airport hangar, concrete floor, liquid all the way down the aisles to keep, to minimise the anything else that's needed in that data center to keep it cool and to maximise the value of the Bitcoin. So we more recently there's been a lot of competition in the liquid space, and a lot of the oil companies have stepped in, so like the Shell, Castrol, Valvoline, but they're all sort of working on who can get the best and the most efficient liquid. About 18 months ago, we were speaking to an independent supplier, and 12,000 litres of liquid a week they were producing and sending out in the Texas area. Now, given that this is a shelf life of about 20 years, it's not like they're renewing it and replacing it. This is all net new that's going out. So it's give you an idea of the scale. So we went from basically traditional data center, and that is actually our servers in that data center, and we moved to this. We take the server, we completely immerse it. It's really simple, really straightforward. We actually take more off the server than we get. Not just the servers though, we do the whole lot. We do the servers, we do the storage devices within the servers. We don't leave that on the outside. We do the network, we do the switches, we do the whole 9 yards. So everything becomes in that liquid environment. We remove all the components that we don't need. We don't need the fans, we don't need anything related to air conditioning anymore or any air cooling. What we found immediately was 20% reduction in the power usage of that particular server or any server. In fact, in fairness, that was an older one. We got about 19 point something. The last one did 21 point whatever. So we measured them before and after when we undertake the work. So we're using it today. We've been using this now live. We've had a customer in there for just over 3 years. Financial services customer. They use it because of the performance. They use it because of obviously the green position of that. And if you want to come and see it, I can quite happily show you around. It's conceptually seems a bit crazy, but reality is there. And this is the benefit. So the high density. I mean, that looks like a standard rack high density. Yet we were at an event yesterday. Myself and my colleague, I'm saying we because I'm staring at him there. The company there was using AI servers, so they're using GPU in the servers. They were getting 6 servers per rack before it was out of power and out of cooling. That's a lot of racks, a lot of space and a lot of money for something that we could quite happily, this small unit here will quite happily cool 50 kilowatts of power. So we're literally back to back to back to back. It's because it's so much more efficient, 23 times more efficient than air, and it's encapsulated, it's even better. We can deal with it, we can move it, we can measure it, we can control absolutely every element of that. We get better performance out of the hardware, which I'll show you in a slide in a second, because that's the one that seems a bit unbelievable. We're using obviously less energy direct, but we're not using any air conditioning for this. So we're actually saving the data center a massive amount. That PUE suddenly drops right through the floor because we're not taking any additional position on that, or minimal position on that. And improved reliability. The reliability is actually a really difficult one to prove because obviously you need the longevity to be able to prove that you've got the reliability. However, once this has been in, and our maintenance costs have drawn through the floor because we've really not had to touch it. But the reliability came out of a study where they removed the air from the data center, replaced that because Microsoft actually immersed the data center. So they removed the air, replaced that with nitrogen, and then found out the components were surviving so much longer because they didn't have any oxidization of components. The whole components that are sat in here are much more stable. We don't have any fluctuations. We can see exactly where the temperatures are on every part. And it's not just focused on one part, it's the whole position. Finally, noise pollution. How strange is it to walk in a data center where it's quiet and yet everything's still busy whirring away. My Spanish event has gone now. I'll have to think of a new one. So I'm just going to touch on performance because this surprised and shocked and really got us. We did testing to a degree that as a cloud provider we'd never really have to go to that level before. We hammered a couple of CPUs in identical boxes, one in air, one in liquid. The top line is the air and the bottom line is the liquid. You see the immediate differential in temperature considering they're running exactly the same workload. There was no external influence whatsoever, there was no network, there was no other element. We were very precise in the way we ran this, and there was a 2-stage testing. What you see across the top though was there was an awful lot of drops and blips and thermal throttling that you never normally see because it just gets dealt with. So we've never seen it, we've never measured it, we expect a server to run. Actually, when it's running full pelt, it does fluctuate quite dramatically. And yet, ours was running in liquid, obviously much lower temperature. The actual differential between the two is the processors weren't aligned next to each other. So we had a slight temperature differential because of the height of the tank, the height of the liquid in the tank. And if we were clever enough, overclocking would be great. And I say that because we had somebody from a storage magazine came in to see us last week, and so the week before, and I've never seen anything like it. It was just like, there you go, and it's running faster. Like, fair play. So let's come back to the environmental. So the whole point was we wanted to tackle the source. I heard this comment ages ago. I've heard two really good comments. One was about Kermit and it's really hard being green, which I really appreciated. And the other one was not to kick the dog and then donate money to the RSPCA. You know, because there's no point using it and then say, oh, but we're planting all these trees and we're doing all this and we're doing all that. Stop using it. Slow down. The less we use, doesn't matter what it is, the less you consume, the better it's going to be. So that was our initial premise of use less, but deliver, you know, for the same delivery. So we've reduced the we reduced the use of air conditioning, we've reduced the power consumption, like for like, still measured today, servers in liquid, servers in air, live measurements, you can see the same workload running. It's not our technology, this is not true. All we've done is adapted what was already there and made it so that it works with off-the-shelf positioning, off-the-shelf servers. It doesn't need any special change or special equipment that you have to go off and buy. We simplify the model more than anything. So a simplified model from our side leads to a simplified data center model, and it leads to these concrete floors, leads to this lack of air conditioning, leads to the fact that they can reduce so much more in the data center than we could ever do, but we're an enabler to enable that to happen, which is why we wanted to start doing this and why we wanted to make sure that we put the network in and why we make sure we put the storage in. So there's no excuse to say, well, it's here, but in the other room we've got all the dirty stuff that we're still on, it's cool. Reduce carbon footprint, so we are extending the life, we are definitely reducing the life cycle around this. We have to compete obviously with software companies that want you to upgrade constantly and want you to move forward and tell you that your stuff is now too old. But with the extension of component life is certainly in place, and the heat transfer, creating a transferable heat source. So we want to build, we want to build this. There we go. And this is our vision of, I want to walk in a data center that looks like this, that's actually got more in it, despite the fact that it looks a lot more sparse. I've pinched this from a company called GRC, they're one of the tank providers in the world. So solid floors, no chillers, no aircon, nice heat exchanger, heat local network, PUE of 1.04. Enormous difference. And we're not throwing all that heat into the atmosphere. Just to give you, I'll just pan that out quickly. We were talking about this. It's the panacea. It's not, there are use cases, there are positions, but if we have heat, what can we do with it? We must be able to do something with it. We can put it into a heat network. We're not going to be able to heat the heat network. It's a guarantee. But we can put it into the return source so that there's a higher temperature coming in. You're not boiling a kettle from cold, you're boiling it from a warm position. We can use it for many other sources. There's been a lot in the press about heating leisure centres and heating swimming pools and various other parts. We're not delivering 100 degrees of heat. There's a limit of what can be delivered, but better reuse it and save the energy from somewhere else. And we've got the capability to do that. The more we can reuse of the heat, the more we're saving from elsewhere. So just to recap, this is me done. If there are any questions, by the way, I'm walking away from the mic again, I'm not used to this. If there are any questions, I'm around literally all day, so feel free to ask us about what we've got. It is all live, but just to recap. So from our perspective, low energy. I can't emphasise water enough. I haven't really touched on it properly, but the amount of water use is just horrendous. Noise pollution, small footprints, and we can still use that 100% sustainable energy source that everybody talks about that we've clearly got, but obviously in real world we know we haven't, but yeah, we can still push that story. Benefits realistically, high performance, standard cloud, high availability, flexible delivery. Part of the reason for using this as a cloud is it can be consumed. We can be part of that scope 3 position without anybody dipping their toe, to excuse the pun, into some new technology or some new area. You just consume it as a normal cloud service. So it's ready for high demand and it's more sustainable. Thank you very much. We're having a panel.
Yeah, let's see. So we're Thank you so much, Martin. That was really interesting. I really appreciate it. I just wanted to, we're slightly behind time, so I do have a load of questions I can ask and do a sort of panel, but I thought it might be more effective to hand over to you and see if we have any questions from you first. So I have a hand mic. Do we have any questions? Sorry.
Hiya. The question is, we talk about data centers of the futures moving forward, but there's a lot of hardware and infrastructure in the current servers that is there any focus around replacing those, retrofitting those, making them internally? Because you think 100 years from now, we can't just keep building more and more and more data centers. And with the emergence of, TikTok and technology, the demand is just going through the roof. So do we go back to the beginning and say, right, well, actually, we need something that's more efficient, that can do more, produce more, use less, and look at what we've already got rather than moving forward and saying, well, okay, next time we'll use these.
So you're basically asking me what we're going to do with the legacy estate?
Yeah.
Yeah, so the problem with the legacy estate is that it was designed probably for 0.5 kilowatts per rack, and now we're looking at 100, 500 kilowatts per rack under AI. But even in the UK today, if you were to look at the legacy estate, you'd be hard pushed to get 5 kilowatts a rack. So this is why we've got these specialist places, and the legacy estate needs a lot of infrastructure upgrades. Now, personally, I think that we should be looking at retrofitting all of the legacy estate, putting more power in, because now we've got, at the moment, because of the lack of power density per rack, a customer, like Martin said, you come in, you can only put one AI server in, and you have to buy 10 racks off of the colo provider and leave 8 of them empty, or 9 of them empty, just to get the power to the 10th one. So if they start to increase the power density in these switches, I can absolutely see that happening. Remember, they have some advantages. They have already got the connectivity, they have the power connection, they have lots of space, and they're centrally located and everybody knows where they are, and they've got all the perimeter security, blah, 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 blah. It's whether or not they want to spend the money on the retrofit and how do you do that retrofit. So technically what I would do is I'd build a new facility and I'd migrate all my customers out of that facility, move them into the new facility, and then retrofit. But you do get some difficult customers who won't want to move. Right, so it's a long, it's a project management function. It's how you provide that transition. So I absolutely do. Well, and in fact, the National Planning Policy Framework will focus on brownfield, greyfield over greenfield, and that is a decision that they've decided to take. I was looking at a site yesterday, which is. It's classed as greenbelt, but literally it's on the other side of a roundabout of a huge industrial area, and I'm kind of thinking, should that even be greenbelt? Because it is literally on the other side of the road. But hey, what do you think, Martin?
I can only work off what we've got at the moment. We've not seen net new build. Right? Be nice, because net new build would give us the reuse. Genuinely, we haven't got at the moment. We're working in an existing data centre. We've tagged onto the end of a rear door rail, so there was water cooling already available in the data centre. We are also in a new facility now that we're just about to launch a product from, and they've taken a completely separate room stroke facility next to the main data floor. So they're sharing the facilities from that, sharing the power, the connectivity, everything else, but they're using that as their starting point of, this is where this part will build, the original will remain, things will gradually move across, and then we can start to move some walls around and shift things that way. So I've not seen the net new, and probably because it takes so long to plan, build, break ground. And for us, net new is a problem because it doesn't have connectivity. As I said, we want the data center as it is now. We want it to adapt. Some are feasible. Some I've got the head in the sand and we'll never do it. The rack I showed you there is literally it's on a data center floor. It's on a raised floor. It's quite happy sat along its compatriots in air, but it doesn't get the full benefit. But what I'm showing is, if it did move forward, we would be able to get the full benefit, and we would be able to, gradually be able to reduce the aircon, gradually be able to reduce the things, especially if you put some walls in place to stop the airflow movement.
But coming on that note, so lack of new build, really, what we need to be doing is any new development, and I mean residential, commercial, anyone. The architects and the developers need to understand the potential for liquid cooled compute and immersed compute and local district heating networks. Yeah. And then we can implement them in. It's really difficult to retrofit a Peasoup or any immersed compute server into an existing district heating network because we're not providing the heat that's required, because they are likely to be generation 3 networks that working at between 90 and 110 degrees C. The output from an immersed compute solution is going to be in the range of 50 to 65, and that's really if you're pushing it. Yeah. So I can absolutely see new build on the high density in edge environments. And we do have, we were talking about this earlier actually. So, immersed compute in a district heating system, yes, we can provide heat, but it's not going to be as optimal as it could be. Really, the ideal solution for immersed compute technologies is in generation 5 heat networks, which operate about between 20 and 35 degrees. And that kind of points towards underfloor heating, which is not prevalent in the UK, right? It's usually a customer. It's not, you can't go in to buy a house from Barrett's with underfloor heating. So there's a lot of things that need to happen at that house building level, and they need to understand, but it's a new technology, even underfloor heating is a new technology, it's been around since year dot. So there's a lot of things, the connections are there, but unfortunately they're not joined yet.
We have a great demo that we carry around, and I actually didn't see it on that slide. I'm sure we'd left it in by mistake. Literally, server in liquid, attached to a radiator. Simple as. And you can touch the radiator's nice and hot. It serves our purpose. It keeps the liquid cool for the server, and the server's just running away with itself quite happily. It's all there and feasible. It's just how do we get it to fruition? But proving the technology first stage.
John, you spoke about the raise. Looked like it was exponential in the data use. Is there anybody looking at the amount of data that's being used and how to reduce it? I'm just thinking simplistic terms, like my cloud server has got my photos on that I never look at. Yeah. And when that gets full up, I can then pay X amount of money and have another chunk, and that will fill up with all my photos again and other stuff. So
yes, so there is more data. Right, there'll be more data tomorrow than there has ever been today, right, or in the past. So data is on an absolutely phenomenal exponential rate, and something like 90% of it's never even looked at again. So, but you're quite right. The cloud companies make a lot of money about providing storage for you not to look at your photographs that you've got on your thing. So and the question we've had I think this is an ethical question, right? So I'm talking to one of the research institutes, and we're going to prepare a paper called "The Nature of Data." Right? Effectively, what we're going to explore is, should data have a time to live tag on it, right? And I think a lot of people are online who unfortunately have now passed away, but they've still got a digital presence. You can see it on LinkedIn, you can see it on Facebook, right? And that's going to be there for as long as Facebook and LinkedIn are around. You will always be able to find that. So should there be some sort of mechanism that it's only got 100-year lifetime before it disappears? Should there be digital detox day where people go around, and in fact there is a digital detox day, and people are required to basically look through and get rid of the crap that they've got accumulated in all sorts of places. But should that be down to the personal level, or should that be down to a corporate? Now, there are some data deduplication software, so that will basically trawl through your storage arrays, and it will look and say, right, you've got 2 incidents of this particular file, we'll get rid of one. But we are the arbiters. We are the creators of that crap data, right? And maybe we should put a link. I've lost count of the amount of times I've seen people go, you see it cascading around an organisation. Somebody gets a meme in from one of their friends, and all of a sudden it gets copied around to everybody. Fine. You shouldn't be allowed to do that. That's a corporate kind of housekeeping exercise. But what would be better would be to put that in the SharePoint and provide people with a link to where it is, so you've only got one piece of data and people linking into it. But that's housekeeping stuff. And don't get me wrong, if we did have some good housekeepers, right, we would probably reduce the energy consumption of IT in the storage area by 50% straight away. But I wanted to tell you something else. I saw a guy last week in Las Vegas, and it's a company called Cerabytes, and what they're doing is laser etched long-term storage, and they're basically creating a pane of glass, and that pane of glass, one pane of glass, will take in a complete storage array onto glass. And I think that's really exciting. So if you do want to keep your crap data, you can put it on a nice pane of glass.
I was going to say, I think we'll come back to the AI conversation. It was a really good intelligent use for AI. Because you're not just looking at the file and the size of the file, you're actually looking at the content of the file, and you can pull up and say, of these 300 selfies you've taken today, which one do you want? Get rid of the rest. And AI could then be actually a really useful commodity that could clean up, because nobody wants to sit down and do it. That's what it comes down to.
I wouldn't be at all surprised if the storage companies haven't already done that, and they've been doing some stuff.
Probably bought it and hidden it so you don't do it, so you can charge them more.
Yeah. No, I was actually thinking they're probably doing it themselves, and if they're seeing one, you might see it as being on your system, but actually it is in a share somewhere, and all you're clicking on is a link to where it is.
Well, if everybody shared enough data, and the storage companies shared their content together, we could dedupe to there's a finite limit on dedupe.
Yeah,
could be done.
I mean,
but anyway, that's
one of my slides had business models must change. That's one of them. So these business models have to change. You can't have a consumptive business model and expect to meet your climate goals or your sustainability goals.
I've moved down here because I'm just conscious of the time. Are there any other questions? Just one more quick one, because we're quite tight for time.
Just one very quick one if I want. First of all, thank you for two excellent presentations. Can we talk about the hyperscalers? We've not mentioned them yet. Very basic question. What percentage market share do they represent? They make big claims around sustainability. I was at one of the hyperscale events yesterday, and one of their slides was all our energy is 100% green sourced already. Could you just give a little bit of market perspective of market share and where the hyperscalers are, please?
Okay, so hyperscalers basically fall. So there are two types of data center. There's an enterprise and a colo, right? So an enterprise is where you own and manage your own facility, and a colo is where a professional outfit will own and manage the facility for multiple customers. Hyperscaler operators fall into both camps. So they actually do have their own facilities, which they run and manage themselves, and they're also the anchor tenants in some of the co-location facilities, and you'll find that they have an entire floor, right, or two floors will be theirs. So it's difficult to ascertain how much estate they've got, right, in the first place, because they're just tied up with so many non-disclosure agreements. I know for a fact that there's a data center in Slough that's got 2 floors of an AWS instance. You speak to that company and go, are AWS in your building? They would say, no comment, right? But I know for a fact that they are there. So it's very difficult to find out the true extent of their activities. Now, are they 100% green? Yes, they're probably doing that, but it's location-based PPA agreements. So power purchase agreements, they basically entered into an agreement to buy a certain amount of power that is ostensibly green from verified sources. Their actual power they use will very much depend on where they are, right? Because the greenness is virtual, basically, right? The actual is your power density of your grid. So, for instance, there's another app, I didn't show it, but there's another app called electricitymaps.org, and even the Nesco app, will tell you, and I'm going to look it up now. I don't know if I'll get access to it, but let's have a look. It will show you what the grid intensity is right now in the UK, right? No, it's saying I can't access the data, so, okay. So what you'll find is Scotland is mostly green, so it's around 12 kilowatt. That's 12 grams of carbon per kilowatt. You come down to London and the South East, it's likely to be up in 230 grams per kilowatt. You go to France, it's 27 grams per kilowatt. If you're in a French data centre in France, you are truly on green power. If you are in Poland, which uses 90% lignite, which is dirty brown coal, you're looking at 500, 600 grams per kilowatt. You go to India, you're looking at 900 grams per kilowatt. So where you're based will determine your actual greenness of your electricity. Now what the hyperscalers do is they offset all of that and basically buy the equivalent amount of green power from somewhere else. So that's when they're saying it. So yes, it's all very good. Are they greenwashing? Massively. Massively. Are they efficient? But you could argue that they are efficient because they are running data centers with PUEs really low, 1.2, 1.3. I think the average fleet of Google is 1.3, which isn't bad. AWS, it's so difficult getting data out of them. I mean, they're impossible to deal with. And Meta, again, Facebook, Azure, they will rather point you towards tools to measure your own carbon footprint in their estate rather than tell you what theirs is. Yes, so the hyperscalers, work in progress, need to improve. And there's a colleague of mine called Mark Butcher from Positive, and he is constantly on LinkedIn moaning about the lack of transparency from the big cloud players. And he's actually working with government. So the UK government is actually getting quite annoyed of the reluctance of the cloud players to provide the information, but then they provide other benefits, which I can't really talk about.
Okay, thank you everyone.